Welcome everyone. It's good to be almost back from vacations. I'm still on vacation, so I actually have the permission to fail somewhat. I was thinking about discussing engineering security today, and I will focus on discussing maybe another angle on security than we normally discuss, and also connect that hard to one of the new courses we're developing in the program PROMIS. So it's an educational program. I'll come more to that later. Since we're not that many, please feel free to kind of put your questions in the chat, and we can then take them as we see them or afterwards. Good. So I was thinking about starting a little with preemptive security, which is not really new, and it's been discussed a lot, but it's not really been applied that much and also not researched that much. When you search for preemptive security or engineering security, which is basically how you figure out how to engineer secure systems from the start and not post-fact, it's kind of like non-functional aspects. Everybody talks about them, but then nobody really figures out how to preemptively engineer them into systems, but it's rather what it ends up as to some extent. Unless it's a dedicated system for a specific purpose, then it can be focused. So basically, this can be kind of summarized if you look at it through different types of engineering and the area of security. Normally what we're talking about is kind of in the middle, and that's operational security. And most security, the security classes I took when I was a student, the security classes that generally are given, which can be really good, generally is on operations. And basically figuring out what happened, figuring out what the issue is, finding gaps, finding threats, and then addressing the threats in products and systems post-fact. And this is all fine. Of course, it's not 100% orthogonal, but you kind of put in a lot of effort into monitoring security post-fact and then addressing issues after the fact when something happened. And then you have another part of security in this security teachings and research, which is basically technology-based, and basically developing new technologies, new ways of thinking, new tools, new languages, algorithms, standards, which is also put a lot of effort into research. And it's basically, of course, it often builds on problems that are present in reality, that you kind of then invent new tech to solve the problem. And this is very engineering focused also, of course, because you as an engineers would like to solve problems. But the third one, which we call engineering security or security engineering, is how do we build in security into products and services, in software intensive products and services, before we actually have a product. And this is kind of the hard part. Because, I mean, fixing something afterward is generally harder, takes time, exposes you for risk, and also makes it very, very expensive to expose your non-secure product to a market or a customer base without actually having security in place. Now, the really interesting thing about this is, I'm not saying that this is wrong in terms of, security is a problem. No, what I'm saying is it's kind of a natural thing. I mean, if you look at non-functional aspects in general, so look at, for example, usability, right? And people say, that's hard. No, it's as hard as anything else. I mean, usability as an example is what makes or breaks a product. Yeah, I mean, there are many products out there that are super feature rich, very good designed and cheap, that nobody uses. But then we have products that are not that good and have many problems, but people use a lot. Now if we really think about this, we can actually take Zoom as an example. Zoom is probably the most user-friendly and flexible way to have online collaborations. There's nothing else we're using it now. However, it is fundamentally full of challenges, like any software. I mean, you know, the security scare that's been around for some time now, but that doesn't matter, because Zoom is still one of the most flexible and feature-rich ones, which also has scalability in terms of volume. And then you have to ask yourself, well, why didn't Zoom plan for security, more security up front? Well, one, there was a trade-off, right? Security hinders usability to some extent. And the interesting thing about that is usability and security are literally two non-functional aspects. So if you don't look at security as an engineer, or as a nerd, or as a scientist, or as a cracker, hacker, call it what you will, but you look at it as a customer and as a product manager, for example, it is generally a trade-off. Usability, security, all those are literally user experience, maintainability, performance. All of these are non-functional aspects. From my perspective, it's just another aspect. Yeah, I'm not saying it's good or bad. I'm not saying it's not important. I'm just saying it's just an aspect. And the fundamental problem with these aspects is that if you're going to figure out how to do it well or good enough, you need to do that when you're planning to develop the product, not after the product has been developed. And that's kind of very hard for non-functional aspects. Functionality is actually much easier, right? So the system should have a button that is share, and share should share the screen. Well, that's functionality. However, how well this works, if it is secure or not, that's also partly satisfied by functionality, but it's a non-functional aspect. And this is very hard in general to plan for. It is very harder to test than functionality, but also harder to estimate the impact before the product exists. And that's the kind of the challenge with security from a product development standpoint, is how do you plan for good enough security before you have a product? So before you have security experts, I mean, literally you're sitting in a room thinking about, okay, what should the product contain? How should it work? How should we design it? But then you can always have a purist view and say, oh, it should be 100% secure. Yeah, but the only way to do that is not, it's kind of put it on a server and bury it in the ground and put cement on it and guards around it. So that doesn't work. Okay. Well, we need a connection, to other systems. Well, yeah, but then you expose yourself to problems. And as a purist, you can always say, yeah, well, we invest a huge amount of time into security and securing the system and making sure it works very well in terms of security. Yeah, but that works fine as an academic. But how do you handle this in a world where you have 5 million and you have 6 months to release a product? Then it literally is, you have 1,000 features you need to implement, and you have 25, 30 non-functional aspects, of which usability, for example, is one, security is one, maintainability, portability, interoperability, expandability, all of these non-functional aspects, they compete with each other. 1 hour you don't spend on figuring out how usability works is 1 hour you can spend on security, and vice versa. So from a theoretical standpoint, yes, you could make it secure or usable, but from a practical perspective, it's a trade-off. And it's very interesting if you go out into industry, and as a researcher, I might not have the best credibility to talk about the industry, but I actually work a lot with companies, and I've had my own companies. And I know that the most common thing I sweat as a product owner or as an investor is that, what should I commit to? What's good enough? That's a very, very hard question to answer before the product exists. If the product exists and it's out on the market, people are using it. You can use usage statistics, and you can use opinions and views from customers and users as input to guess this. Because make no mistake, this is not science, it's guesswork. And best guess wins. And the more data you have input, the better guesses you can make. So the idea behind dividing security into 3 parts is not saying it's orthogonal. It's not. I mean, of course, they relate. What I'm saying is that if you look at it from an operational standpoint, it's generally monitoring, detection, it's evolution, maintenance, it is what happens, feeding engineering to some extent, but also post-production and post-development. Technology is the base technology you can utilize in operations and engineering engineering is trying to guess what's good enough and how to do it well enough and trade off before you've actually done it. And those are kind of 3 important perspectives to have because all of them are equally important. But operations is probably the one that is most focused on, and technology then, and then engineering is talked a lot about, but nobody's figured it out, really. And I think I read 150 papers or glanced at 150 papers in the area, and most of them end with, we don't know enough about this, we need to do more research. And this started 15, 20 years ago when they said this, and the latest paper I read, which was published 6 months ago, still said the same thing. So that's kind of what we're discussing today. So what is it? Well, if we look at it, you kind of, it's not really, it doesn't really look like this. It more looks like a feedback cycle. Because of course, when you have a previous experience from a product, for example, an operating system, you collect the information about what attacks are there, how usable a product is, how good it is. And then of course, you feed the next generation of systems. And it's not like the first system ever developed, which means you can still use customer feedback even if the system doesn't exist. And basically, if you divide it into different parts, you can say that privacy, integrity, safety, and others, basically non-functional aspects, is what the engineering part cares about. While the operational part of the equation is more how you solve it. And that's another view you can have. And I'm not saying, and this is very important, I'm not saying one is more important than the other. I'm saying that if you don't have a good engineering, a good security view, and a realization of the trade-off in engineering, your operations will be harder and your technology won't help you. That's kind of the core of this. And I would say it's the fundamental problem is this. If you have security nerds who are really into security, they are super good at solutions. But they, even if they conceptually understand it, they don't really get that it's a trade-off. And it doesn't matter if you have a secure system if nobody wants to use it because it's not usable and it doesn't contain the features you like. It can be the most secure system in the world, nobody will care. And this is very hard to kind of get if you haven't been there. And then on the other hand, you have engineers who only focus on, I want to deliver the product, I don't really care about anything else. They have a very hard time figuring out the technology needed and the operational part of it, which means they don't know how to design a system that's secure without overdoing it. And this is kind of the balance that I think is very interesting for future work, both in terms of future work, in terms of developing of new ways to educate engineers, software engineers, but also in terms of challenges for researchers, because researchers are working in their hole. Researchers in general, they kind of penetrate a very narrow hole and try to solve a very specific problem. And the more narrow the hole is, the more abstract and irrelevant it is for application in reality. Because researchers aren't solving reality problems many times, they're solving very specific detailed problems that eventually might be part of reality and everyday life. But in the short term, they're not. Because you have to specialize so much when you're doing research that you're not capable of abstracting it to a real scenario, because it's so isolated, it doesn't work in isolation. But you have to work in isolation to be able to do research that contributes to something. And this is kind of a major problem. And when we as engineering researchers come in, we try to kind of take base research and apply it. But in the engineering part of security, there's very little done. There's some good practices and some frameworks you can use, but nobody's actually been able to say, okay, but how do you do a trade-off between usability and for example, usability and security? Nobody's solved that problem. Nobody's calculated it. Nobody's figured out how to do that consistently over products over time. But rather you make a guess, and if you're lucky, the guess is reasonable. If you're unlucky, you have huge glaring security holes in a very successful and popular product. And then you, in panic, need to fix the problem, but also build back trust once the problem has occurred. And this is kind of the reality, but it isn't uncommon, and it's not very removed from any other non-functional aspects. And that's kind of what I think is very interesting and a very good opportunity to do new work and also to train engineers in. And I think that what we need to do is kind of bring security nerds and software engineering nerds together to kind of formulate new knowledge that is practically applicable, but also takes advantage of the very real cutting-edge technology and cutting-edge knowledge in operations. And I would like to see, we talk about DevOps, for example, and we talk about agile methodologies, where especially, I mean, if you look at it, you know, bringing experts together and everybody's a tester, everybody's a developer. Yeah, but everybody should also be a security expert or a security engineer. So I would say that you need three things. You need the super experts in security, but you also need every engineer that's working on a product needs to understand enough security to know when to ask the questions they need to answer. Every manager in any company that develops anything needs to understand why you should literally have a priority of security over usability, over feature, over maintainability, over releasing fast the product. Every top manager needs to understand that preemptive investment into a thing that, if it works, isn't seen, which is very weird, right, is literally a good idea. And not after it failed, you kind of, oh, we have to fix. And now we have to invest 10 million. No, you need to do that preemptively. And that's the hard part. It's a very hard selling point. Because if I'm a product manager in a company, I want the product to be released as fast as possible, as cheap as possible, just outperforming the competition, not more, because the second it radically outperforms the competition, it is literally gold plating, and it's only a waste of my time because I could have released faster and cheaper. That's kind of my purview. The point for me as a product manager, just be slightly better than competition, slightly faster, slightly cheaper. While a real nerd, it doesn't matter if it's a security nerd or if it's any other nerd, and I say nerd with love, not with any critique. They generally want to do something as good as they can. And this is a conflict, and it's a healthy conflict, I think. But it's also a problem when it comes to a specific area that is not understood by everybody else. And I think security is one of them. Usability is getting better as a non-functional aspect because people have kind of figured out that if nobody likes to use a system, it won't really perform, even if it's feature-rich. But I think that security is well-researched and well-expert, but I think the preemptive engineering part is not understood well. I mean, most software engineers take 1 or 2 courses in some sort of security that's very technical. But none of the engineers take a course that actually covers how you do a security risk analysis properly, or how do you trade off and stop doing security during development because it's good enough? And that's kind of an interesting idea that we should probably explore. So what am I talking about? Well, if you look at secure engineering security or secure engineering or preemptive security, basically we have to put it into a software development lifecycle of some sort. It doesn't matter really what flavor of Pop-Tart you're using currently. I mean, it doesn't matter. I mean, it doesn't matter if you do DevOps or if you do Safe or Safe++ or whatever they're calling the latest version. It's basically the same thing. You need to figure out what to do. You need to plan for doing it. You need to actually do it. And then you need to figure out if you did it and if somebody cares, and then you continue and repeat. If you do this in a big cycle over a year, if you do this in small cycles over a week, doesn't matter. It's fundamentally the same thing. And when you figure out how to do it, that's generally called requirements engineering of some sort. It doesn't matter if you don't call it that. It's still requirements engineering. Requirements basically is the demands on the system, what you want it to do. Then if you do this with post-it notes or telelogic doors, doesn't matter. It's literally the same thing. And yes, I mean, there are benefits to thinking about this as a continuous small cycle where you can make mistakes. But you still end up with the same problem, is that you select a fundamental architecture, for example, for a system. It's not something you can change every week, right? I mean, you can change the fundamental, you can't change the programming language every week. You can't change the architecture of the system every week. You can't change which third-party modules you have bought to use in your system every week, so every iteration, right? So you still need to take kind of fundamental decisions that will impact your product development and future for a long time at least, or an expensive time. And it doesn't matter if you do it in a week's iterations or a year's iterations, 10 years iterations. You still have the same fundamental problem. Somebody has to decide which programming language to use, for example. And here, security comes into play. Because if you look at it, right, you can use third-party components. You can generally use programming language. You can still fix usability fairly easily by putting layers on it. I'm not saying it's a good way, but you generally can. What's exposed to the user is one thing. But from a fundamental thing like maintainability of a system or security of a system, the fundamental decisions you take in terms of modularity and in terms of which architecture you select, which languages you select, radically impacts what you can do from the non-functional aspects perspective, for example, maintainability or security, much more. Which means that the decisions you take dictate the ability you have to fulfill the non-functional aspects for a very long time. You can deliver features every week, but you can't change the big things every week. And that's kind of why security is one of the unique non-functional aspects that we need to take into consideration much earlier. And not, yeah, it needs to be secure. Or trying to solve it with obvious functionality. Yeah, you know, we'll have encryption. Or, yeah, but we've had access restriction, right? We'll have access restriction, it's fine. Yeah, but that doesn't necessarily solve the problem. So what I'm saying about this is that we, in the software development lifecycle, need to figure out that we need to elevate security up front to a degree that's equal to functionality. And that's very hard because the second you have a non-functional aspect, it's generally harder to estimate because it impacts all the functionality. So non-functional aspect is literally a qualifier of functionality and more. And that's very hard to estimate and it's very hard to test because everything is impacted by it, but it doesn't stand alone. And that's the fundamental problem we have with doing this preemptively before it's done. You can argue, ignore everything, just develop the system and then fix the problems as we go. And I think that might be a good strategy to some extent, but I think it's a very dangerous strategy, especially with integrated systems today. I mean, would you like to just release a cool autopilot in Tesla and then fix all the security issues post-fact? Of course, you do that anyway when you figure out you forgot some, but you can't do it with everything. And that's kind of why we need it early in the requirement cycle. So what is security in software-intensive product and service development? Well, I'm going to talk a little about this soon, but in generally, we are developing a program in security which offers advanced level education in security. And that will basically be a number of courses we are developing. And one of them is about the topic I'm discussing today, which is kind of an introduction to preemptive or engineering security. So basically, how do we give our engineers a good enough understanding of security to be able to build in as much as, to take as much preemptive action as possible without trading off only towards security. You can, see it as a design course, right? I mean, if you want your engineers to be better at usability, well, you don't talk about usability and give them more programming. What you do is you teach them design. You teach them human cognition. You teach them how people are using products, what works, what doesn't work. And the same thing here. We need to train and supply better training for engineers in security, but they shouldn't become a security expert, because then you kind of defeat the purpose. I'm not saying security experts aren't important. I'm just saying we need engineers too, who actually focus on developing the product, which is not made for security, it's made to be secure. And that's a big difference. So if we look at this, we see an introduction to security is needed because I see the target group that's important to address early is developers, absolutely, but also managers and semi-non-technical people. So for example, customer experts, customer responsibles, they who are literally out in the field with the customer, adapting the products so that the customer can use them, for example, well, selling the products, figuring out how to collaborate with other vendors or products to combine functionality. That's very important. Managers, well, now I'm generalizing, but generally managers are the people kind of tasked with the decisions. See a product manager, for example, right? The person who kind of plans the long-term development and evolution of a product. They need to understand the importance of security and what goes and what does not, and what works and what does not, and how expensive it is. But also both expensive in terms of preemptively doing it, but also in terms of how costly will it be to fix the problem after it happens. And being able to have some tools to do this proactively. And to be able to do this, security analysis is part of this, which is risk and trade-off analysis, cost and trade-off, and also trade-offs between different non-functional aspects. I mean, I have a link to further reading in the end of the slide set, which I'll share. But in generally, I think it's healthy to see security as a non-functional aspect as important as any other non-functional aspect. And if you see it like that, you kind of see it as an engineer, in my opinion, because there are some systems that it doesn't matter if they're secure, as long as they're fun to use. A security company is one thing, but any company developing products, depending on what they're developing the product for, some systems don't have to be secure. Doesn't matter if they're not. They need to be fun or fast to use or simple to use. Other systems are super critical that they're engineered securely, but generally they're harder to use. And figuring this out as a product manager early is important. And then you don't have security experts necessarily, but rather you have a bunch of people sitting in a room discussing the product. And what tools can we give these people to actually do a better preemptive job in this? There's a course that's going to be given in the PROMIS program, which is called actually Security in Software Intensive Product and Service Development. The reason why it's so long is it is not only software. I mean, everything is software today, which means a car, for example, well, they have the same challenges. And the product managers for a car, or the product managers for Zoom, or the product managers for any piece of any app or a piece of software, but also a truck. So it's basically the same knowledge you need to have and the same trade-off analysis you need to do, but your priorities are different. So of course, security as a non-functional aspect in an airplane is a hell of a lot higher than in a wine app on my iPhone, where I kind of photograph labels of wine bottles and get recommendations. Right? I mean, there's a fundamental difference in the non-functional aspects are important. But the problem is still fundamentally the same for an airplane or a wine app. There's not a big difference there. What priorities you have and what's important is, but the input you have is the same. So if we go and look at the actual course, which I am not an expert in, and this is kind of important. I'll share that later, but we have two new colleagues who kind of working on this course in the area who are a hell of a lot more experts than I am. I just know I'm not good enough as an engineer to figure this out. That's kind of my background. And I would say that you can do many routes here because security is a big area. But we generally in the course have an introduction, and we are looking at the OWASP framework and also the Microsoft Software Development Lifecycle Framework. That's kind of a basis for how you can address security from an operational development perspective. And the idea is that you can take these lessons and apply it to your environment, even if you work DevOps or if you work in another methodology. It doesn't really matter because, you know, requirements, figuring out what to do, how to measure if you've done it, if you're compliant, what tools to use, how to test it, how to design it. Those are kind of fundamentals independent of methodology. We also look into risk assessment. So the idea with risk assessment, of course, is guesswork early. But the guesswork is more in a structured form, so you can kind of figure out what the rating and likelihood and impact of the risks are, security risks in this case, and also what actions to take if they realize, and which risks are so important or so dangerous, it's worth preemptively trying to avoid them. Threat modeling is another thing, and I would say threat modeling is a very interesting area because you have a progressiveness of the area, which means that look at pre-pandemic times, you know, Zoom was yet another reasonably interesting app. But, and I guarantee you that the people that developed Zoom knew that there were holes in security, but they did a threat model and said, yeah, but it's okay because it's easier to use and it's, you know, simpler than the competitors who are maybe more secure, but it's okay for our threat level. But then when things exploded and kind of people started using it for much more different purposes than originally intended or originally used, all of a sudden things were exposed. I mean, there's a natural thing that the more users you have, the more holes are exposed. But in Zoom's case, it wasn't only that, but also that the users were different and the use cases changed, which means that their modeling of the threat, and they did that, they maybe not using an official tool to do it, but they still sat down with a whiteboard and thought, you know, how open is the system, how secure it is. And their threats changed over time depending on the usage of the product. So does risk. And this is a very hard thing because as a product manager, you need to plan, you know, 2 years in advance of a product that's released every 2 weeks if you do cyclic, right? And guessing the future is kind of hard. If it wasn't, then we would have a different discussion. and that's kind of interesting. But as I say, when I do risk analysis, when I do risk analysis, I kind of use a couple of tools for this, and I kind of do it in a structured way as I'm used to. But the structure and the product of the risk analysis is not the purpose. The purpose is doing it continuously so that you can actually brainstorm on what issues are around. And I think that threat modeling and risk assessment, risk analysis, all of these are ways to do this. And the question is, how can you do it for security reasons? Another thing is third-party security implications. So basically, very few systems are developed from scratch. Okay, you're reusing components. What does that mean? What challenges does that introduce? Or you're buying products from a third party. I mean, look at 5G in the world, right? And so how can we take this into consideration? I think that's more and more important. But I'll also say emerging properties, right? So for example, if you have a system or a product that you're releasing, which the customer or the user actually can control the evolution of to some extent, right? So they can combine your product and somebody else's product, right? In their iPhone, just as an example. How do you preemptively take this into consideration? And this is kind of an interesting thing. And of course, then we have this testing part. Testing is not only post-product testing, but also verification and validation overall, which means that you have pre-executionable testing of things. You can also simulate environments, and etc. And the idea is not for anyone taking this course to become a super expert in this, but rather know pros and cons, know what's out there, know what methods you can apply when needed to actually try to be more preemptive and secure engineer. And I want to say it again, the idea with the course and this introduction to this area is not only developers, but I would say it's even more important for managers to kind of get the feeling for what's possible and what's expensive, what's cheap, how much should you invest, depending on your context. Then, of course, another part of it is secure programming, which is more technical, but it's also very important for, I would say, non-developers. Sorry, it's very important for developers to understand this, no discussion, because when you take programming decisions, which you generally do on the fly, out of a utilitarian perspective, right, you're kind of making it work. You need to know what you're doing and what the implications that has. But that's actually easier, I would say, than for a manager to understand that the coding will take 10% longer for this product iteration because of we are committed to security. And I would say that it's very easy for a non-expert to sit and say, yeah, but just make it secure. And I think that's cheating. I think that even non-technical people who do not code, need to understand some basics about coding and security. And I would say that I think that Alex and Vlad, who are the main teachers of this course, are really good at that, because they are so good at this that they literally can make stupid examples for people like me. So they should be able to explain it to almost anybody. And then we have also, obvious connection to operational security is incident response and post-release planning of operations, which means that, so to make a system secure, you can do it through feature set and non-functional aspects, or you can do it through having an open system but actually monitoring problems, right? I mean, you can solve a problem in different ways. Just as you can solve a feature in different ways, you can solve security in different ways. So what should you solve preemptively? What should you solve through code or design or architecture of the system, versus what should you solve by monitoring or fixing post-fact, right? So for example, instead of having a huge amount of intrusion detection in a system, you could literally have huge amount of post-release monitoring to see abnormal behavior and catch the problem with people who are in the system who shouldn't be after it's released. I mean, I know it's a stupid example. It's too perfect because you don't do either, you do both. But the general idea is that you can solve a problem in many ways, and you can also solve security in different ways. You can actually choose to solve it by having reactive measures instead of proactive measures. So intrusion versus access restriction versus intrusion detection is kind of an example of this. And this is also a trade-off, right? I mean, but this trade-off needs to be done early, not afterwards, but rather when you plan a product, you should kind of figure out which are the pros and cons for this. So that's kind of the idea. So this course, just examples of contents of the course. The idea with the course is to kind of speak to developers who want to learn more about development of software-intensive products and services and security in security aspects, managers and semi-non-technical people working in product development or associated fields. Everybody asleep or everybody awake? It's very hard to read the room when everybody's non-dreaming quiet. I hope everybody's alive at least. That's a good indication. So what am I talking about? Well, I'm talking about PROMIS. So it's basically an educational program. The difference between PROMIS and a normal university education is that PROMIS is basically an educational program. PROMIS stands for Professional Master in Information Security. But in general, what it is it's a bunch of courses put into a program that is around security. So that's kind of the idea. And you have many courses here. We will have maybe 20, 30 courses in the area. And the general format is that we are developing these courses to be taken by people working already. I'm not saying students can't take it. I'm saying the idea behind the courses is that they're done on distance. They're done with case-based reasoning, which means that you can bring your problem from your company into the course and kind of get some support for solving the problem. Which means that the idea behind the assignment is we don't give an abstract assignment, but rather you can bring your own ideas into the assignment. That's kind of the flexibility. It's more focused on feedback and discussion than necessarily only teaching. So it's online and it's collaborative based. And the idea is that it should be open and accessible for people already working as a manager or as a developer or equivalent, and taking the course and kind of trying to balance that with their normal work, family, and everything else. That's why it's spread over longer time, the courses, and also case-based and online, which means you can do it on a Saturday evening instead of doing it Monday to Friday. That's kind of the idea. But it's an industry, it shouldn't be confused with industry professional courses, the 2-day, go to a course building and the company pays money and you're there and drinking coffee and having a nice time for 2 days and you kind of get a diploma in the end. No, this is a university grade education, which means you actually get points and it's a proper education on the advanced level. So every course is a proper university course. So the requirements and the work you have to put in is much higher than normal industry courses. However, we are trying to kind of meet in the middle, so it's adapted to be relevant for industry, but also possible for people working in industry to take the course, and at the same time, university grade. And this is a very hard trade-off, but we've been working a long time with this, and we have very good experiences from this. And the idea is that we have a bunch of partner companies, and we are still looking for new partner companies. But the idea with the partner companies is that they literally are attached to the courses we develop to kind of give us input. So it's not a huge amount of work, but they can kind of meet us, present their challenges, So for example, if a company, I don't know if Telia is with us still, but I know they were early. But if Telia, for example, wants to send 10 of their engineers to take the course, they can be a partner company, which means that literally they can actually tell us, yeah, we have this problem, we would like our engineers to take this course. Then we can kind of adapt the education as we go. And that's kind of the idea behind it. So if you're interested in being a partner company, just contact us and we'll explain what it means. But the idea is to be able to influence the actual contents of the courses we're giving, and also get some benefits of early access to the courses for the people working in the companies. And that's kind of the trade-off. And the work for company partners is very little. It's kind of a couple of meetings and a couple of sessions and discussions. So it's not a big deal. There's no money involved really. And PROMIS is basically given by BTH at present, in collaboration with KKS Knowledge Foundation, who graciously supplies the funding and some expertise. And the idea is that we will develop this program over time to include more and more courses in different areas. Thus far, we have 3 courses, and I'll shortly just go over them very shortly. So we have one that is called Software Security, which Dragos is the boss of. And I would say that this is a really good but more operational course for understanding and handling security issues. And I would say that it's a good, maybe not the first introduction course, but it's a good introduction course to the security area, but slightly more from an operational perspective. And I would say that the second course we're developing is more applied towards web-based security, and it's given by a bunch of people, but Anders Karlsson is the boss of this course. Boss of the course basically means that's the person you mail to ask questions, nothing else. We're kind of, everybody's collaborating, many people collaborating on giving a course. It's a big thing. I would say that web-based security is more applied from a web-based perspective, and also more slightly more practical in terms of doing. And the third course is the course in the area we've more been discussing today, which is basically preemptive engineering of security and what to think of. And I would say that course, yes, it has a lot of practical moments, but it's also slightly more theoretical and slightly more introductory in nature, because it needs to cover a very wide array of things, which means you don't go that deep into doing. But I think it's more suited towards giving engineers and managers and non-technical people to some extent a wider understanding of security as a field and why it's important to think proactively about it than post-fact. And so the PROMIS program we're discussing is basically university, which means that it's free to apply for everybody in the European Union, and Sweden, of course. And basically, you apply through normal channels as you would in any course. The difference is it's for industrial people, so people working in industry. So basically, you go to the normal places to create an account and to do your application, which is Antagning.se or universityadmissions.se. And you can actually search for the courses in PROMIS. You can always also go to promisedu.se, where all the courses are listed and all this information is available, including these slides actually. But the idea is that you can actually apply for the courses through this, and your prerequisites literally are a bachelor's in a relevant area, but it can be anything from information systems, software engineering to computer science. Doesn't matter, it should just be 90 ECTS in technical areas. But here's something very important. First of all, you can still apply. And the deadline for application is actually the 31st of August. even if formally the applications have ended, but it hasn't. So you can actually apply still this year and subsequently. But also, if you don't formally have a bachelor's in a technical area as a base, you can still get into the courses if you have something that's called real competence or equivalent competence. And that basically means that if you've been working as a developer, you've been working as a product manager, you've been working as an engineer, it doesn't really matter, for a time, and you don't have the formal university points, but you literally have the knowledge, we can actually count that as towards you having the competence to take the course, which means you will probably get in if you're knowledgeable. Because the really, really weird thing about academics is that we assume that if you have 90 CTS, you're good. Well, I would say half of the really good people in engineering don't have any formal education at all. So then they shouldn't be allowed. No, that doesn't work. So we've tried to be super flexible. So if you want to take the course, which I really recommend you doing if you're interested in security, know something about it, but you don't know enough, which is probably most people, including me. I would literally apply for the course as soon as possible, and you send in motivations for your background, and then we'll try to judge that as you being able to take the course, even if you don't have the formal points. So don't sweat it too much. And if you have any questions about the course specifically, in the slides you have the email addresses to the course responsibles, and they can always answer the questions. If you have any questions in relation to the PROMIS program, in general, you can mail me or Anna primarily. And apply. The worst thing is you don't get it. But if you're interested in the area, chances are you'll get in. Because chances are, if you're interested in the area, you know enough to be qualified to start learning, and that's kind of cool. So I put a couple of links here into papers that are kind of related to preemptive engineering, security engineering. None of them are good. Some are okay, but it's kind of an unexplored area. So we're working on it. Thank you very much. Any questions?